everybody. It's my great honor to introduce our next speaker, Eric. Eric is a technical fellow and director at Microsoft Research. He has made contributions in the area of machine learning, perception, and decision-making. He has been awarded the Alan Newell Award and the Feigenbaum Prize for his research. He is a fellow at the AAI, ACM, National Academy of Engineering, and the American Academy of Arts and Sciences. Beyond technical advances, he has been interested in the influences of AI on people and society. As the president of AAAI, he organized meetings on long-term AI future and later founded the 100-year study on AI. He is also a co-founder of the recently launched partnership on AI. He received his PhD from Stanford University and asked if it's okay to speak at an MIT event. I think we'd be okay with that. With that, please welcome Eric.
Okay, thanks very much. Thank you very much. So we've all seen these kinds of graphs and charts about why we're at where we are right now. It's been a bit magical over the last 12 years in particular the last maybe 9 years. People should keep in mind, though, that AI advances have been diffusing into society for decades. In the late 90s, handwriting recognition was diffused into the U.S. Postal Service, and billions of letters are being examined every year, saving millions and millions of dollars. It's a beautiful pipeline that goes from the handwriting back to language models. In other areas, we've seen some really interesting dips, and this was surprising to me as a long-term AI researcher. In 2009, at Microsoft Research, we rediscovered deep learning. So, it's like a round of applause. So this was actually work when Jeff Hinton visited us, and we discovered that deep learning procedures were actually, all these years had been ravished for more data. They were hungry. And when we fed them that data, we got those kinds of leaps down. This is the switchboard data set of conversational speech. Here's the human level. And back a few years ago, we said, wow, wouldn't it be great to reach a human level of understanding in the wild conversational speech on telephones collected by an unnamed government agency for purposes. But on the way down, we found, like in other companies, Google and Amazon and other companies and startups, that we could do new kinds of things completely, like Skype Translate among many languages now, and field that. But along the way, just recently, in October, our team hit human parity in conversational speech, and we expect this to happen in other areas of perception. Our Chinese lab, our MSRA China, hit human levels in one of the ImageNet tasks earlier. So listening to speech, fabulous. Seeing has been another great place for innovations. It's been remarkable seeing what came out of just after Microsoft Research published the COCO data set, challenge set on image captioning. We thought, it'll take a while to figure that one out because it's pretty challenging. And at the same time, independently, Google Research, Stanford, and Microsoft published CVPR papers. I think Microsoft was leading in the category there, but that's okay. I think we tied in. There's 3 different categories. We tied in one with the Google folks. But it's great the fact that different teams doing this. And now we have democratized methods. This is part of the Cognitive Service API, which is similar to Amazon's, we just heard, suite of APIs that come along with the cloud services with Azure. What's amazing, though, is now we can sort of take these kinds of things and go further. Like, what about recognizing human gesture, hands? If we can recognize hands, how would that work? This is a video just came out this year that shows this is not a video, but this is a model, a generative model of human hand and gesture at a distance. I've often said if you can get thumb and forefinger into digital spaces, you can build civilizations there. And it's just been really impressive with how far we've gone just at a distance, really understanding with machine learning, in this case, really the pose of a hand. Now we can combine speech, natural language, planning algorithms, and vision together to build new kinds of ecosystems of servants and services. So this is our directions robot at Microsoft Research. We have one at every floor. This is my digital assistant. We call it the assistant, which has about 16 years of my data. I can pause there for a second and think about that. But she knows more about whether I'll attend a meeting or not then my admin, my human admin. She watches my calendar all these years. She gives me reports and so on. Really shows the power of the integration. So we're seeing new opportunities to harness AI to assist, to empower, and to protect. To give you a sense for the powerful tools that are just out there now, like for the taking, this is Shakib, a developer at Microsoft, who grabbed with a small group some of the tools and said, he's a sight-impaired person. What could I do with existing tools off the shelf, kind of like COTS, and built the system with this group. Here's a little bit of him talking about one particular part that makes my eyes wet a bit when I hear about this. A little bit more volume.
I see two faces, 40-year-old men with the beard looking surprised, 20-year-old women looking happy.
So I love the fact that we can help there. Now, thinking about assisting, here's human-powered drones. And who's trying to fly a drone around here? This is kind of what you get typically. not all the time, of course. We take them to the ski lodges and we try to fly these things and watch a ski. And this person here, I think, is having a particularly bad day with his drone. And I think just when things look really good, I think he runs out of power. It's kind of a cute little video segment, but it's a real one. So what can we do? What can we do there? So we just built a system called AirSim and shipped it on GitHub. I have to say, it was to Diane, it was trending ahead of TensorFlow out on GitHub when we launched this. But imagine now flying drones with drone hardware that inject their drone commands into this rich simulation environment, complete with sensors that are reasonable and reliably matching what drones would see with those sensors. And we can use various learning algorithms to learn through thousands of trials, just like AlphaGo might learn with trillions. It's a little harder with open world issues, open world contexts. But really learn how to fly these things and to empower them to be autonomous someday and safe. One thing that really intrigues me, given my background, I did an MD PhD at Stanford. My background in working in AI for healthcare is the high stakes AI. What is possible there? I'm on the advisory board of Johns Hopkins these days, and I'm really impressed with what Johns Hopkins has done with vision and surgery. This work was done by Carol Wiley and others several years back, but the idea was, can vision algorithms understand the semantics and the language of surgery to detect these kinds of moves that a human surgeon might be taking? And this kind of work led about a year ago to this kind of mixed initiative collaboration between machines and human surgeons on a very complex repair called an anastomosis repair, kind of a tube-to-tube repair. And it's just impressive to see the collaboration. And to me, this gives me a glimmer of where things are going when it comes to the future of work, in this case, in a physical space. But the automated system is imaging with infrared, in this case, the seams, and understands how to do stitching, understands the human role, and there's a back and forth collaboration going on. One area that our lab is now looking very carefully at, that I feel very passionately about, is where can AI do the most social good where it's not being used today? About a year and a half ago, an article came out, this is the second in a series, that the third most common cause of death in the US is preventable error in hospitals, preventable human error, right after cancer and heart disease. What can be done? Could AI provide safety nets, like under the bridge builders? And we're building models, for example, surprise models, that are built with data sets that enable AI systems to reason at the frontier of human knowledge rather than replicate it, to reason about when an expert will be surprised by a patient diagnosis or a readmission coming within 48 hours. We also have a real big opportunity. This is, of course, a well-known one with automobiles. I lost my mother to a car accident. Chunks of my family, a whole family from Palo Alto, was killed on the way up on a camping trip a few years ago, the Howards. there's a death every 25 seconds in the world, about 100 U.S. deaths per day. I always say, if you want to make the United States safer, work on this problem, not some other, random political, sort of motivated challenge, right? Work on these problems. This is making us unsafe, these problems here, and AI can go a long way to helping. So I drive a Tesla. I really enjoy it. It's getting there. It's a semi-automated experience. But beyond Teslas, car consortiums are now working on automatic braking systems using machine intelligence to have the right kind of false positive, true positive rates that make it tolerable and safe. If you drive a Tesla, you'll know that the models sometimes understand, sometimes accurately, when they can no longer help, when they need to turn things over to the human being. But more generally, think about the challenge of designing AI for the open world. Not everything can be really thought about in advance typically. This is one of my problems on the Tesla. One night on the highway and cones were closing a lane and my Tesla didn't recognize that. I was alert to that fact. On the way to an exec retreat last week at Suncadia, my Tesla ran into these rear ends. And I just didn't even want to guess what would happen. I took over. So there are rising concerns with AI. I want to talk a little bit about that because I think for us as a community to get the most out of AI, we have to address the rough edges and downsides as well. So just a couple things. First of all, as I mentioned before, there's going to be a challenge of creating robust, trustworthy systems in the open world outside the laboratory. We'll need to understand what best practices are for fielding technologies, even cars in the future, when they're new and we're learning. Another interesting challenge is the challenge of ethics. So typically there's split-second decisions that are being made, and when you have a reasoning system that for it's like a year of human time or more, of course, and injury and death is likely, and split-second choices must be made about whom to put at risk. And we can represent in our systems value functions about what we care about. Who assesses them, who reveals them to the driver, who's at liability. Big questions are coming up in this area. Another concern for me, and this is what keeps me up at night sometimes, is that AI components being embedded in our hardware, in our Internet of Things, in our practices and workflows, introduces new attack surfaces. Let me show you some examples of some recent work. This just got accepted, this paper, by a group at Penn State. We see a neural net here, input on the left, right is the inferences. Typically, we care about the categories. This is a machine vision network. Imagine it being used in an automobile. And there's a rising field of adversarial machine learning. So this team showed how you can take a system trained to see traffic signs and manipulate that sign bit by bit to create this sign, which I can't even tell the difference of when I look at it close up on a computer screen. But the machine vision algorithm sees yield. Same here. All these signs can be hacked adversarially. Cybersecurity in general is going to be a challenge for AI as well as against AI attacks that are persistent. I'm also concerned about using AI to target minds. Recent work, this recently published work, shows how you can manipulate minds with large bodies of data. In this case, the Twitter fire hose can be used to learn a lot about the masses and to tirelessly target individuals. So this tweet here was written by a neural network, written end-to-end by a neural net, designed to make someone click on that link. And what's amazing in this work is they actually look at what topics does an individual tweet about. When does she respond? What event has she attended? And even looking at Twitter feeds, where is she now? To get that, and they show multiple hundreds of percents rates of increase in click-through. There's also interesting implications there for freedom and democracy, of course. And look at this work from Stanford, from last CVPR, forthcoming CVPR. Using vision and graphics, we're going to map the source actor smoothly onto the face of powerful individuals. Now, when this was created, this work, I don't think Donald Trump was our president yet. So it probably wasn't as serious a video in terms of what the implications might be. But it's just amazing. My colleagues in AI research believe that within a few years, we'll be able to synthesize in a way you can't discriminate any human being in terms of a media feed or source. What will this mean for democracy and freedom in the future? What will it mean during a time of adversarial conflict? So, and finally, another area that bothers me is machine bias. It's amazing how fast we started using data sets everywhere, including criminal justice systems, advising judges, for example, on whether to let somebody go in advance of their court date if they can't afford bail. A whole jail at Dade County was closed because of the money savings that came out of this. But an analysis shows there's some biases in that system and some poor practices, like using data from one city to make inferences on another. And so people have looked at, what are the implications of our systems amplifying biases in our society that are implicit deep in our data sets? And of course, the AI and job situation. Look, there's probably going to be disruptions in different sectors as we augment as well as replace jobs with the intellectual power of AI. But we also know that AI is going to create tremendous wealth. How can these treasures be shared? We have a report, I was on this committee, coming out this week after about 2 years of work from the National Academy of Science. A couple of pictures that show some interesting trends, like the difference between the GDP and the median family income. It's separating, which means wealth is not going to the average. It's going to a narrow segment. Or looking at how getting from high school, the bottom curve, or even finishing college doesn't really compete with the grad school, and how that might relate to what's going on with voting, and you can sort of look at some of the trends. So the question I have is, in some ways, is what do we do about this, even if implications of AI and war and peace? And I think the idea is we have to lean in. Okay, so in 2009, we did a set of studies at AAAI that led to a set of discussions that was so valuable, I thought, on ethics and law and long-term futures that in 2014, I decided we should do this again. And so we created what's called the 100-year study on AI at Stanford. The idea here is to have this kind of study happen every 5 years for as long as Stanford survives. And just to give you a sense for some of the first report, some of the findings in the first report, there's an implication of a need to engage because near-term design and policy decisions are likely to have long-lasting influences, and that we need to bring in social scientists, policymakers, legal people, and others to understand how to engage. It's not just going to be a geek fest. We have to really think broadly and deeply. We can also do other kinds of meetings. We just had in Arizona a really fabulous several days where we invited people to envision worst-case AI nightmares. We changed the title to make it a little bit more acceptable. Write them down and have a red team and blue team go at one another. This is Kathleen Fisher overseeing the Cybersecurity AI Challenge, and it was a fabulous set of meetings. That's a little headline that came out of that work. And finally, we can get together as companies and nonprofits, NGOs, to work together. And I'm very excited to have co-chaired the Partnership on AI, which has brought together Amazon, Microsoft, Google, Facebook, IBM, and Apple, along with nonprofit sectors in the civil liberties, AI scientists, nonprofit AI research, and foundations, and others. Together, we're going to basically work really hard on some of these tenets that we all agree to, like we're committed to open research and dialogue on the ethical, social, and economic implications of AI, and we seek to develop AI research and technology, this is all the companies, that is robust, reliable, trustworthy, and operates within secure constraints. So the future is in our hands. Thanks for your time.